Welcome to Vidyaachem Coaching Classes. I am Darshana ma'am. For 12th standard, one of the important chapter is Halogen Derivatives. So today we are going to learn nucleophilic substitution reaction mechanism. So there are two mechanisms, SN2 and SN1. SN2 mechanism meaning is nucleophilic substitution by a molecular reaction, by molecular reaction. And its example is methyl bromide, alkyl halide, when reacted with aqueous NaOH. Simply that halogen is substituted by nucleophile OH minus, and you will get methanol, methyl alcohol, and your leaving group is Br minus, bromide ion. So why order is 2 for this reaction? Reason is, as per kinetic studies, rate of reaction is dependent upon concentration of methyl bromide as well as concentration of nucleophile. And that's why with respect to alkyl halide order is 1. With respect to OH minus order is 1. And overall order of that reaction is 2. And that's why it follows second order kinetics. This is the reason. Next, actual mechanism. How that reaction takes place. Mechanism का मतलब है step wise description of that reaction. So this is your substrate. Substrate. ये देखो CH3Br methyl bromide. This is a wedge formula. Normal wedge means those groups present in the plane. Dotted wedge means behind the plane, and solid wedge meaning is those groups present above the plane. So there is an attack of nucleophile OH minus on methyl bromide, formation of transition state, this is a transition state, always written in square bracket because high energy state is there and very unstable. -1 up, -1 up. देखो, carbon to oxygen bond formation takes place and carbon to bromine bond breaking takes place. And that's why there is a simultaneous making and breaking of bond takes place. Single step mechanism is there. And that whole -1 charge is distributed on both OH minus and Br minus. So it's a pentacoordinate carbon. Transition state देखो, carbon is pentacoordinate. Normal valency of carbon is 4. And that's why these two bonds are written as dotted line. C2O and C2Br. And finally, you will get methyl alcohol plus Br minus, leaving group. Formation of CH3OH, methyl alcohol and Br minus. Main feature of this reaction. First, single step reaction is there. Already I explained you. There is a simultaneous breaking and making of bond takes place. That's why single step is there. Second point, backside attack of nucleophile. देखो attack कैसे nucleophile का. Both possibilities are there. Nucleophile can attack from front side or back side, but backside attack is favorable. First reason is your leaving group is also negatively charged and incoming nucleophile is also negatively charged. So repulsive interaction takes place. First. And second reason, crowded groups. If crowded groups are present, then backside attack is more favorable. Next, for optically active substrate. So methyl bromide is optically inactive because 3 same groups are present. No chiral carbon is there. But in case of optically active substrate means which possess chiral carbon, asymmetric carbon, in that case, always inversion of configuration takes place. Inversion means ये ऐसे image है, then you will get like this. जो group left hand side में, वो right hand side में होगे. And simple example is, it just like a flipping of umbrella. So in case of optically active substrate, inversion of configuration takes place. Flipping of umbrella. And stereochemistry means surrounding that chiral carbon, whatever groups or group of atom attached and their position in space. It's a stereochemistry, which is known as Walden inversion. Walden inversion. Then factors affecting rate of this reaction. Which factors will increase the rate of reaction? So first factor is substrate कैसे होना चाहिए, alkyl halide कैसे होना चाहिए. देखो methyl bromide is a primary alkyl halide. So primary alkyl halides are more favorable for SN2 mechanism. And again its reason is crowding effect. Okay. Then strength of nucleophile. Nucleophile कैसे होना चाहिए? So nucleophile also required in first step. Both substrate, alkyl halide and attacking reagent nucleophile required in first step, and that's why strong nucleophile is required. Strong nucleophile is required, which enhances the rate of reaction. And third factor, nature of solvent. देखो nucleophile strong, तो solvent कैसे होना चाहिए? Less polar solvent and aprotic increases the rate of reaction. Suppose your solvent is polar, then what will happen? That polar solvent will stabilize the nucleophile. So nucleophile, its activity decreases, and that's why your solvent should be less polar and aprotic. So these factors are responsible for rate of this reaction. So this is what about SN2 mechanism.